Hello class, welcome to this lesson 4.2 on conditional probability. So let's get started. So how are we going to do this? I'm going to explain to you two problems, guys, and we're going to do them. This problem number one and another problem. I should have placed a number two here. I'm sorry. These two are different problems, right? And then we're going to have a theoretical approach so we can find a formula for the probability of A given B. So let's start. Problem number one. What do we have here? We have a set of cards, a set of 10 cards numerated from 1 to 10, and they are properly shuffled. And then we're going to select a card at random. Fine. So we have these 10 cards, right? And the first instruction is find the sample space. In this case, it's very simple. The sample space is equal to the set of all these possible individual outcomes. The first card, the second card, the card number 3, etc. up until the card number 10. So these are all the individual outcomes that I can get out of this experiment of selecting a card at random. Okay. Number 2, calculate the probability of A given B. This is how you read this, guys. I'm gonna say that again. The probability of A given B. The probability of event A happening given that we know that the event B has already happened. That's what this symbol means. So we want to find this out. And what does this mean? I mean, in layman terms, what is up with this? Okay. So basically, guys, all these symbols tells you is that you want to calculate the probability of this particular event once you know this event has happened. And basically, I mean, that's what you get when you read it, right? The probability of A given B. The probability of A once you know that B has occurred. That's all this symbol means. In this case, what are my events A and my event B? Well, the event A is the card is 2, and the event B is the card is even. So what we're trying to calculate in this particular problem, what we want to calculate is this: the probability that the selected card is 2, given that we know that the card is even. We already know that, guys. We select one of these at random, one of these cards at random. Let's suppose that I put it here and I put it face down, so we don't know the number, right? But let's suppose that you have information about this. You have some information. What do you know? You know that the card is even. You know this. So how does that change the probability of A? This card being the number 2. You see? So first, let's do this, guys. What is the probability of A? The probability of the card being 2 on its own. When we pick up a card from this set, then you should agree with me that the probability of the card being 2 is 1 out of 10, right? Okay, this is quite simple to understand. Now, can we calculate also independently the probability of B, which is the probability of the card being even? Yes. How many even numbers we have? We have 5 out of 10 possible ones. So the probability of the card being even is 5 over 10. So we know these two probabilities. But what is the probability of the card being the number 2, given that we know that the card is even? How do we solve this problem? What we do is this, guys. We, let's say we recognize the new sample space. Okay, something I like to call this new sample space. I like to call it the collapsed sample space. I'm gonna tell you what I mean by this in a moment. This is the original sample space, right? There is no doubt about this. Okay, but once you know, guys, once you know that the card is even, then the sample space will collapse into a new sample space. What is now the sample space? Now that you know that this card is even, the new sample space, which I may call SC for collapsed, this is not a standard notation. This is just my notation, and you can use it or you can use something different. This is just in order to differentiate this from this original sample space. So the collapsed sample space, now it's going to be the following. Now that I know that the card is even, then the only possibilities for this card is the number 2, the number 4, the number 6, the number 8, and the number 10. This is my collapsed sample space. El espacio de muestra colapsado. Okay, very good. And now that I know that this is my new sample space, then what is the probability of this card being this one, the number 2? Well, I have only this possibility. This is the favorable outcome out of 5 possible ones, and therefore we can say that the probability of A given B, the probability of the card being 2, given that we know that the card is even, will be 1/5. 1/5. You see? That is the probability of A given B. It's going to be 1/5, which is neither this one nor this one. Can you see? This is, well, 1/5 is going to be equal to 2/10, right? So it's different from the probability of A, and it's different from the probability of B. So that's how you solve this problem. 2/10, period. Let's move on. Same context. We have the same set of cards, numerated from 1 to 10. And once again, we're gonna select at random one of these cards. All right. Let's find sample space. Once again, it's gonna be the same thing. This is the original sample space. And now, what is the thing that we want to investigate? We want to calculate the probability of A given B. But now, what is A and what is B? What kind of events are they? The event A is the card is even. The event B is the card is prime. Okay, memorize that. A, the card is even. B, the card is prime. So let's find out. Once again, just for fun, let's calculate the probability of A, which is the probability of the card being even. As we know, that's going to be 5/10. Got it. Let's calculate, just for fun, the probability of B, which is the probability of the card being prime. How many primes do we have? We have the number 2, 3, 5, and 7. That's it. So we have 4 out of 10. So these are the individual probabilities of events A and event B. But I want these guys. The probability of A given B. That's what I want. Okay. So what's going to happen? The event B is going to happen, and then I need to assess the probability of A once I know that that event B has happened. What is event B? The card is prime. So we select a card out of these 10. Here it is. We put it face down, and we know, for some reason, we know that this card is prime. The card is prime. And once I know this, I ask myself, what is the probability of A? What is the probability of the card being even, given that I know that the card is prime? This is what that means. So let's see. What is my new sample space? Once I know that the card is prime, then the collapsed sample space is going to be 2, 3, 5, and 7, which are all the primes between 1 and 10. This is my new sample space, or the collapsed sample space. This was the original sample space. This is the new sample space. All right, and then now that I know this, now that I know that this is my sample space, what is the probability of the card being an even number? Well, only the number 2 is an even number out of 4 possible cases. Therefore, it's very simple to say that the probability of A given B, the probability of the card being even, once I know that the card is prime, will be just 1 out of 4. There you go. So this is my solution to this problem, 1/4. Memorize this because now we're going to go backwards. We're going to find the probability of B given A. The probability that the card is prime, once I know that the card is even. Is it going to be the same as this? We don't know. Let's find out. So, what is the collapsed sample space? Now that we know that this has taken place, okay, now that I pick up a card, I put it face down, and I know that the card is even, then my collapsed sample space is going to be 2, 4, 6, 8, and 10, right? And then, out of these possibilities, which one is prime? Well, only this one, right? This is the only prime number out of these 5. So the probability of B given A, the probability that the card will be prime, once I know that the card is even, is going to be 1 out of 5. There you go. And if you remember, the other probability, this one, was 1/4. So this alone proves you that in general, the probability of A given B is not going to be the same as the probability of B given A. In general, they may be the same, but in general they're not. Okay, guys. So, can we find a theoretical approach? Can we find a formula for the probability of A given B? Yes, we can, and I'm gonna show you how. The first thing I want you to remember is this, guys. I want you to remember that in a Venn diagram, if you remember, they were these sort of things, the rectangles in which we draw events and so on. We can represent the probability of an event A by the ratio of its area to the area of the sample space. So all of this is the sample space. And let's suppose I have in here an event A. I'm going to draw it as a circle. And this is event A, all of this. So what this tells you guys is that the area of this circle relative to the area of this rectangle, the area, let's say the area of event A in relation to the area of the sample space, that's what we know as the probability of A, right? It's just the area of this event, of this circle in this case, relative to the area of the sample space. That's what the probability of A means. And if we consider the area of the sample space as 1, okay, for example, if I consider the area of the sample space as 1, then the probability of A is equal to the area of this circle A. Okay, now what about this? What if I draw this? I'm gonna draw a sample space for any particular experiment. I'm gonna draw event A and event B. Okay, so what does this mean? What relation do they bear to one another? They are disjoint events, right? Because all the outcomes that are inside event A are completely different to the outcomes of event B. And we can have another possibility given two events, right? Which is this one. We can have this other possibility. This is event A, this is event B, and when they overlap, like in here, when they overlap right here, this is the case in which both events happen at the same time. Why? Because they share outcomes. Remember, this is called disjoint events. This is called joint events. Okay, so this is just a brief reminder of these joint events, Venn diagrams, and the the mathematical significance of the areas of these events, right? All right. So let me draw once again two sample spaces. Let's consider it's the same but replicated, and let's consider two events. First, these joint events A and B, and now joint events A and B. There you go. And we want to find a formula. We want to find a formula for the probability of A given B. The probability of A given B. So this is joint events. All right. So in the first case, guys, in this one, when we have these joint events, what could be the very easy way to calculate the probability of A given B? If I know that event B has happened, let's suppose this is highlighted, meaning that it has already happened, then obviously the event A cannot happen, right? If I know that the outcome, that this event has happened, okay, then therefore what that means automatically, given that they are disjoint, is that the event A cannot happen. So the probability of A given B will be 0 for these joint events, for this case. So this is a very simple formula in the case of these joint events. Let me give an example of this. Suppose that we have the experiment of throwing a die, and I represent event A as getting, I'm gonna try to be very economical here, getting even, and event B as getting odd, an even number or an odd number, right? If I want to calculate the probability of A given B, which in other words is the probability of getting an even number, once I know that I have gotten an odd number, that's going to be clearly 0, right? It's very simple to understand this. This is the good one, the interesting one. So in here, when I have joint events, then what's going to be the probability of A given that we know that the event B has happened? Okay, listen very carefully. I already know that the event B has happened. I already know that. Therefore, basically, guys, I can ignore everything that is outside B. Okay, I only care about this area. I only care about this area because I know that B has already happened. Everything outside B, and I'm gonna try to signal by making this motion, all of these outcomes are completely out of the game. They're no longer important for us. No longer important. Only this matters. This is the collapsed sample space. You see what I mean? Before, the whole sample space was all of this, but now that I know that B has happened, then my new sample space is only B. You see? Okay, so now I ask myself, what is the probability of A has happened? What is the probability that A happens once I know that B happens? Okay, so there are two areas, I'm sorry, which is this one, which I'm going to highlight even more, this area here, and this area in here. Okay, B is composed of this area in here and this other area. Okay, so in which of these two areas, guys, A has happened? In here, right? Only in this area, which is the area that event A and event B shared in common. And if you remember from one of the last lessons, one of the maybe 3 or 4 last lessons, this area or this probability is represented by the probability, well, it is a probability of A and B. This little section here is when both A and B happen at the same time. You see? So this area represents the probability of A given B. And now, Therefore, what is the value of this? What is the probability of A given B? It's going to be the ratio. It's going to be the ratio of this probability, the probability of A and B, the ratio of this area to what? To the whole area of B now, because this is my new sample space, the probability of B. You see, this is the formula, guys. It may be tricky to understand this. I can explain this in Spanish in a moment if you want, if this is not very clear, but let's just write this down. And we're gonna, first of all, the most important thing is to know how to use it. And maybe with time, in a couple of days, 3 or 4 or 5 days, once you study this thing with more care, you can come to understand why this is equal to this. But I'm going to explain this to you in Spanish in a moment. So this is the formula for finding the probability of A given B. It's going to be equal to the probability of A and B over the probability of B. I'm going to stop it right there. See you in a few seconds.